Okay, this is section 11.3 of the Math Power 8 math book, talking about calculating probabilities of events, multiple events occurring. So in grade 7, you learned how to use tables and tree diagrams. And now in grade 8, you learned that if you take individual probabilities of individual events and you multiply them together with other probabilities of events occurring, you can calculate combined events. Like this question. It says a bag contains 3 red marbles and 2 black marbles. The second bag contains 2 pennies and 4 dimes. A marble and coin are drawn from each bag at random. Explain to a classmate who missed the lesson how to calculate the probability of red and a penny. So we consider this one to be event 1 and event 2, drawing from the bag of marbles and then drawing from the bag of coins. The probability of this first event, which is red, would be 3 chances out of the 5 marbles in total. And for penny, it would be 2 pennies out of 6 total coins. So if I was to multiply those together, I would end up with 6 out of 30, which in lowest terms is 1 out of 5, which most of us know is a 20% probability that event will happen. Now, if you don't believe me, you could go revert back to grade 7 and take your marbles down here, red, red. And if you made your table, you can see that red 1 cent, there are only 6 of them, 6 combinations of red 1 cent out of 30 total possible outcomes. But obviously, this method is much easier to use than this method because it's much less labor intensive. But you have to understand this in order to know why this works. In order to know why this works, you have to understand your table. Your second question says, Catherine gives the following explanations for how to calculate probability of black dime. She says that there are 2 choices for marbles. Now, this is going back to our last question, so I should actually probably take this picture. Well, you get the idea. I'll just draw it over here. If I can go one more, there we go. So what is the probability of this? So she says, because there are just black and red, that means there's a 1 chance out of 2 to go with black. But that's not true because there are 3 black marbles and 2 red marbles, which means the probability is not 1 out of 2, it's 3 out of 5 for drawing a black marble. And there are 4 dimes out of the 6 total coins. The probability of a dime is 4 out of 6, which means the overall probability is 12 out of 30, not 1 out of 4. So the mistake she made was she didn't think of how many coins or how many marbles in total were in there and what number of those were either black or dimes. Question 3 says, explain the difference between experimental probability and theoretical probability. Well, the difference between those two, experimental probability, if I took 4 coins, which I did the other day, 4 coins, this will be $1. I took 4 loonies, and I said, what is the probability of flipping heads? And everybody calculated, and they said that heads is 1 out of 16 flips. And then I proceeded to shake the coins up, and I slapped them on my desk, and lo and behold, on the very first flip, it was heads, 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 heads. Now that looks to be 100% probability that was going to happen, but it isn't. It just so happened that it happened on the first flip out of 16. Now, if I was to do it 16 times, it might happen 4 times. It might happen 3 times. It might not happen at all. But what the theoretical probability means, if I was to do it infinitely, and I was to flip those coins an infinite number of times, theoretically, it should happen 1 time out of every 16 flips. Okay, it might happen 2 times out of 16 on one, and then 0 out of 16 on the other, but overall it would average out to be 1 time out of 16. But the experimental probability is what you get if you did it 16 times, how many times it happened. And they could be different. Just the more you do something, the closer it would get to the theoretical probability. So your next question says, Brittany spins a spinner divided into 4 equal regions and rolls the standard dice once. Construct a table to organize the sample space. So for this, here's what your table would look like. And the question says, construct a table to organize the data, a sample space. So there it is there. And we can see that there are 4 times 6, there are 24 possible outcomes. It doesn't ask for anything specific, I don't think, did it? That was a stupid question, wasn't it? That was pretty easy. There are 24 possible combinations. I could do it like this. If I asked you what is the probability of a B1, then the probability of spinning a B on this would be 1 chance out of 2. Or sorry, not 1 chance out of 2. 2 chances out of 4, which is 1 chance out of 2, but I'll write down the proper probability. And the probability of rolling a 1 would be 1 chance out of 6. So the probability of doing a B1 would be 2 chances out of 24 or 1 chance out of 12, which as a percentage is roughly 8 1/3% or 8.3 repeating. Question 5 says Joe takes 1 marble from the first bag and Ron takes a marble from the second bag. Use the multiplication method to calculate the total possible outcomes. Well, there are 4 different marbles in the first bag. There are 5 different marbles in the second bag, so there are 20 possible outcomes. What is the probability of blue-red? So for blue, there are 3 marbles out of 4 in that first bag. And for red, there are 3 marbles out of 5, which means the probability of a blue-red is 9 out of 20, or just less than 50%. It's 45% probability. The next question, a lot of people got this wrong. They had a hard time with it. It says the weather forecaster predicts that the chance of rain today is 75% in Victoria and 20% in Calgary. What is the probability that it will rain in both cities today? So there's 3 ways you can do it. You can first take 75% and just translate it to a fraction, 75% and 20%. And if you multiply those two out, you get 1500 over 10,000. Or if I was to reduce it to a fraction out of 100, it would be 15 out of 100, which is around 15% probability. And it seems counterintuitive because if it's 75% in Victoria and 20% in Calgary, it seems only reasonable to think that the probability of it happening in both events should be the average of those two, which would be, 75 plus 20 is 95. 95 divided by 2 would be 47.5%. But it's not, because the probability is different when you have combined probabilities, and we see it there. This is a great example of where it's counterintuitive to what we normally would think. I could also have taken 75% in lowest terms and 20% in lowest terms and multiplied them out and got 3 out of 20, which is still 15%. But regardless of what method you use, you still find that the probability it's going to rain in both cities is 15%. Great question on counterintuitiveness. Question 11 says, what's the probability of a red-blue combination? In this bag, there are 1, 2, 3, 4, 5, 6, 7 marbles. 5 of them are red. In this bag, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 marbles, and 6 of them are blue. So the combined probability of a red-blue would be 30 out of 70, which is less than 50%. I think it works out to be 42-ish percent. 42-ish percent. Which is a decimal. Sorry, I guess I could be a little bit more accurate with that. 30 divided by 70 is 0.4285771, repeating, because that repeats here, goes 4285771, 4285771, 4285771, 4285771. So if I put the bar notation above all that 6-digit number, and really it's closer to 43%, because it would actually be 42.8%, 42.9%. Okay, so the next question. It says, from a deck of 52 playing cards, a card is drawn at random. Then the card is placed back in the deck and the deck is shuffled. And a second card is drawn at random. Determine the following probabilities. So what's the probability of a 4-7? Well, in a deck of 52 cards, 4 out of 52 are 4s, and 4 out of 52 are 7s. So the combined probability of any 4 and any 7 is 16 chances out of 52 squared, which is 2704, which has a probability of 16 divided by 2704. Oh my heavens, it's not very good. It's 0.0059, or approximately 0.6%, less than 1%. What's the probability of a 4 and then not a 4? Well, again, our 4 we know is 4 to 52 because we just said it. And since 4 of the 52 cards are 4s, there would be 48 out of 52 that are not 4s. A little bit of logic you have to use there. So therefore, we'd have 4 times 48 being 192 chances out of the 2,704 combinations of 2 cards. So 192 divided by the 2704 means you have approximately a 7% probability of a 4 and any other card. And finally, the probability of a 4 is still 4 chances out of 52. The probability of a number less than 4, well, 3s, 2s, and 1s are all numbers less than 4, which means there are 12 cards out of the deck of 52 that are less than 4. So that would be 48 out of 2704. 2704, which means there is roughly, approximately, a 1.8% chance of drawing a 4 with a number less than 4. Is that the last question? One more? Okay. And the last question says, a probability experiment consists of 3 independent events, A, B, and C. And an independent event simply means that what happens in that event is not influenced by other different things. Like, for example, pulling a card out of a deck and then pulling another card out. That's the second time you draw, it changes the probability of an occurrence because there is one less card in the deck. But 2 of these events have probabilities of 1 out of 2 and 3 out of 7. The third probability, probability C, we don't know. So the probability of the first event and the probability of the second event and the probability of the third event, we don't know. But we know that the overall probability of these events occurring is 9 out of 70. So 1 times 3 times something gives you 9, which means this has to be a 3, because 1 times 3 times 3 is 9. And 2 times 7 is 14, or another way to think of it is 2 times what is 10, because I know 10 times 7 is 70. So that means it's 5. So 14 times 5 is 70, which means the probability of that third event had to be a 60% probability event, or a 3 out of 5 probability.